With the advent of artificial intelligence, we have the opportunity to add more value to current examinations. So radiologists today will do their best to get through massive amounts of imaging and pixel data, resulting in a radiology report. But there's additional information typically in examinations, such as an MR or a CAT scan or a PET scan, where we could analyze the data, much richer, deeper data, to be able to pull back data such as radiomics or lesion tracking information to be able to look at prior examinations, current examinations. AI has the ability to enhance the diagnosis by aiding the radiologist with additional information, such as these detailed quantifications. At the end of the AI process, a radiologist could be able to look at that data just like they look at pixel data and be able to get a greater diagnosis. You can imagine a situation where AI not only takes pixel data or image data, but also captures data from the electronic medical record, say for example genetics and genomics, so that the radiologist has even greater information and ability to make an interpretation. Imaging 3.0, the notion was to be able to capture information that comes into radiology through the modalities, also capturing patient information in the electronic health record, and then passing the information that the radiologist creates back out to the electronic record, to the patient, and to the referring clinicians. With the addition of artificial intelligence, it really closes a lot of the loop of the communication pathway so that Imaging 3.0 can be fulfilled. For example, with artificial intelligence, we have the ability to capture a lot of information out of the scanners, make that available to the radiologist, pass that information through over to the EHR so that there's a closed loop process similar to what we've talked about with Imaging 3.0. It's important to note that the radiologist, I think, needs to continuously be in the information loop, serving as the gatekeeper or data manager of the information that's coming through the processes of medical imaging. With the advent of artificial intelligence, we have the ability to create additional information by taking large amounts of data and having inference models to be able to see things inside of the images that the radiologist either might overlook or not be able to see because of the subtle details that data analytic systems can see.
Keep track of what you're saying.
Okay.
All right, ready when you are.
One of the challenges with the creation of artificial intelligence in general is the notion of the different actors that are necessary to come forward to create such solutions. For example, computational companies need to create algorithms in artificial intelligence that have been going on for the last 50 years, but most importantly, with the advent of new technologies in the last 5 to 10 years. Additionally, data is necessary to be pulled out of medical records, PACS systems, various sources with specific to healthcare. A lot of that data is protected behind firewalls. So the data and the algorithms need to come together and create what's called artificial intelligence models. The ability to deliver those models into care is another challenge. And so platform solutions need to be able to integrate AI models into clinical environments. The American College of Radiology sees the challenges that are facing the industry to create artificial intelligence solutions for radiology and radiologists and our patients. And so we created the Data Science Institute in May of 2017. The notion of the Data Science Institute is to focus on advancing some of the activities around data science for the there's like the
We're on the mission of the DSI?
Yeah, exactly. The Data Science Institute was created for the purpose of solving some of those challenges across the industry. So the notion of being able to take data from various sources and organize those, structure those for supervised learning is necessary. To create data sets that are consistent so that the algorithms can use those to create consistent output of prediction inference engines is necessary. The Data Science Institute has envisioned the ability to educate our members, radiologists, our patients, as well as other healthcare providers. It's also the mission of the Data Science Institute to help industry to understand the challenges that we have in medical imaging that we believe that artificial intelligence will help. If we can, start over. I'll keep starting with the Data Science Institute so you can.
Yeah, that's great.
One of the values that the Data Science Institute can bring is the notion of validation of algorithms and the creation of use cases around algorithms. So for example, if industry was to place a competition to identify lung cancer on low-dose CT, one of the things that would be helpful is to have a standardized way to define the predictability of lung cancer on a low-dose CT case. With the advent of, I'm not going to use advent again. with the use of lung RADs, we see that as an endpoint for use cases in artificial intelligence for lung cancer detection. A use case can be created around lung RADs so that algorithm developers can direct the data and direct the solutions toward a prediction model that could make calculations that would populate a lung RADS score. Let me see, what other?
Basically, you've really.
Yeah, I'll drill in a little bit. Data sits in a wide variety of locations, particularly at hospitals, other data sources. It's challenging for industry, computational industry, to extract that data out of the hospital systems. Oftentimes, the clinical expertise, the clinical data, and the clinical environment to use artificial intelligence and oftentimes to develop artificial intelligence is located in the hospitals. We need to create a standard way to define the use cases so that the data can be annotated in a consistent fashion. The Data Science Institute is defining those use cases so that we can have data organized in a structured way, as well as having models, inference models, come out in a structured way that can be implemented consistently inside of clinical care. One of the challenges around artificial intelligence is its newness. There's so much activity happening just in the recent 5 years that education is a challenge. One of the efforts of the Data Science Institute is to continue that educational process out to our members, to let folks know exactly what's going on in the industry, to know what could be coming to their doorsteps in the next few years. It's important to understand and embrace the technology because it really has the opportunity to advance all of what it is that we do, our practices, and patient care. The initiative, let's say,
On this camera.
we've visioned the Data Science Institute of the ACR to act as a honest broker to bring parties together to create algorithms. We don't see that we will be creating algorithms for artificial intelligence. Instead, we see ourselves as creating a foundation, such as the use cases or as the validation methodologies, to ensure consistency and usability across the marketplace for artificial intelligence. Artificial intelligence has been around for about 50 years, but most recently, in the last 5 or 6 years, well, now is that going to be dated too? If we show this. Artificial intelligence has been around for over 50 years, but recently there's been advances that have accelerated the field. The question often is, what does this mean and how does this impact radiology and radiologists? I see the future, at least the near future for 10, 15 years, as focusing on what's called narrow AI versus general AI. And let me explain the difference. In general AI, you would act more like a human child does, where you're able to see the world and start to make inferences in broad senses, to be able to solve major problems. I don't see that happening initially in artificial intelligence. Most of the focus of efforts is in what's called narrow AI. Narrow AI is looking at a specific situation, bringing tremendous amounts of data together, which fuels that rocket for AI to create that solution. For example, the notion of using an AI solution to read an entire CT of the head is far off into the future. The notion of being able to have an algorithm identify a pulmonary nodule on a CT of the chest is something that could reasonably happen in the next few years. So I do think that we're going to have many, many narrow AI solutions that need to be integrated. Now the challenge is not so much how to create those solutions, but how to integrate those solutions into clinical care, into our day-to-day work. You can imagine if we have hundreds, if not thousands, of narrow AI solutions in with the radiologist's interpretation, that we need to make sure that those smoothly flow into what it is that we do, not to slow us down, but to make us more efficient. The goal of this is to improve patient care, improve the quality of care, improve the efficiency of the radiologist, and improve the output of all it is that we do. So some of the work is capturing and organizing the data, making sure that we're answering these narrow problems, but also making sure that the process by which we integrate the human and the machine is optimized. Man, it's getting louder.
Camera 1 is rolling, and whenever you're ready.
If you think about decades ago when PACS came out, or the challenge of digital imaging approached radiology, it was a similar challenge for radiologists. We were all trained at the time to read on film, and we had to transfer our knowledge over to a new environment, digital displays, digital storage.
Can I stop you right there?
Yep.
I'm so sorry. I'll not make a habit of this.
Whenever you're ready.
Okay. Artificial intelligence brings many challenges with it, but it's not unlike the days before when we transferred to a digital environment. If you think back to the days of PACS coming into our departments, there was a big change in the way that we did our work before that. Many people were trained on film, and then in the 90s, early 2000s, had to switch over to a digital environment. We all lived through that transition, and actually record studies show that we're more efficient in this digital environment, but a transition was necessary. Artificial intelligence, I think, is going to be similar to that. And if you think about, also the other challenge was there were many different ways to deploy PACS in the early days. And so DICOM and other standards were created so that there was a more standardized approach to the solutions, consistency across vendors, the ability to interact between vendor solutions and change out vendor solution A to vendor solution B. It's a similar challenge that we have today with artificial intelligence, and one of the motives of the artificial, it's a similar challenge that we have in artificial intelligence today, and one of the considerations of the Data Science Institute is to create standards that will help to move artificial intelligence forward in a similar way that we help to move PACS forward with the DICOM standard. Use cases are going to be essential to have standardized, and validation, verification of the algorithms as they get deployed in the industry are going to be necessary, so that, again, we can have vendor selection choices. We have the ability to have consistency across different solutions that we bring into place.
Rolling. And whenever you're ready.
Because many of the solutions that are to come are what's called narrow artificial intelligence, they're focused in a specific area within our field. For example, the notion of detecting lung cancer is too broad of a challenge for artificial intelligence today. But the ability to identify, say, a lesion like a pulmonary nodule is something that we could see happening in artificial intelligence. That's the definition of narrow AI. And that's also an example of a use case that we would have to define for those that are creating the AI models. Use cases will be proliferated throughout many of the things that we do, in many of the examinations that we perform. If you think of it as when we're looking at an examination, we're trying to identify findings. Each one of those findings are essentially a use case. And if we are to have artificial intelligence aid us in that process, we do need to strictly identify what those use cases are so that the data can be structured in a way that it can optimize the training of algorithms. And also when the output is done, when that AI inference model is created, we can input that data into the electronic record in a very consistent way, regardless of which vendor created the AI solution.
Excellent. Okay. Rolling.
In the near future, I don't see AI replacing radiologists in any way. Instead, I see the opportunity for artificial intelligence to enhance and augment what it is that we do. If you look at what's happened in chess, 20 years ago was when the computer beat the then reigning champion, Kasparov. And now there's a solution called freestyle chess, where humans and computers together play the game against each other. And what they found is that it's not the best human, it's not the best computer, it's the combination of good humans and good computers with a good process that ties those two together that allows for victory. And I think the same thing's going to happen in medical imaging and in healthcare in general. It's going to be a combination of the best of what a computer can bring and the best of what a human can bring together in an organized way with an optimized user interface that really focuses on the solution at hand. If you think about what artificial intelligence will focus on today, as I mentioned, it's narrow artificial intelligence, narrow AI. And I think the ACR and the Data Science Institute needs to help to guide industry toward what those challenges are that we see in the field today that we have every day. And those are the solutions that I think we can drive through the industry with narrow artificial intelligence to augment what it is that we do, to improve the experience that our patients have by combining the human and the machine.
And follow?
No.
Rolling, and whenever you're ready.
We've had computer solutions inside of medical imaging for decades. If you think of conventional computer-aided diagnosis in areas like mammography, they've been there to assist the radiologist. This is something different. Artificial intelligence today takes a completely different approach to creating an inference or a prediction. When you look at conventional programming, computer vision is often what it's called. You take large amounts of data, a human programmer takes large amounts of data and tries to work with the expert to figure out what it is that they see. And then they generate a hand-created algorithm that is able to take in data, say like an image, and be able to predict results. The problem is that once that program is done, to have it get more accurate, it has to be reprogrammed by humans. When you take the approach with artificial intelligence, the more data you add, as long as the data is accurate, the higher the accuracy gets typically. And you can try with new programs. So essentially the data is the program. And now the AI algorithm is essentially the compiler that creates this AI inference model. So you wind up with higher accuracies with larger amounts of data. So let me say that again. When you program by hand to try and create algorithms that can make predictions, it's very human intensive. It takes a considerable amount of work, and once you're done, it can't get any more accurate. When you use artificial intelligence or machine learning to create the inference engine, you start with a large amount of data and you get a certain accuracy. And typically when you add more data, you get even more accurate. So you can see how you don't have to query the expert per se, and you don't have to have the human hand coding. You can now have the computer itself actually creating the algorithm just based on larger and larger amounts of data. And with that, we see higher accuracies through the use of machine learning as opposed to the more traditional computer vision solutions.
Okay. Audio, and we're good.
Let me describe the difference between supervised and unsupervised learning. In supervised learning, you have the data and the structured answer to the data. For example, if I were to take 1,000 cases of lung nodule or no lung nodule on a chest CT, there was an answer with that says that the radiologist saw that there was a lung nodule. Or you could go even further and say a biopsy was performed and it turned out that that nodule was cancerous or non-cancerous. That ground truth, as it's called, is necessary to train a computer in a supervised learning mode. That's typically what happens today in machine learning or artificial intelligence. So you need to curate that data, structure the data, add ground truth to the data so that you can use the algorithm can see that ground truth and uses that to create that inference model. In unsupervised learning, the answer is not necessary. The computer takes large amounts of data and tries to separate as best it can and identify things that are different. So for example, things that have a nodule, things that don't have a nodule, things that cause cancer, things that don't cause cancer. As you can imagine, it's much more difficult to do unsupervised learning, particularly today. And so what we see is a lot of the successful attempts at artificial intelligence in medical imaging today are around supervised learning. The challenge with supervised learning is, as I mentioned, you need to have ground truth. So that typically means that you have to annotate the image data with the answer. Where is the lesion? What is the lesion? Is there a lesion? And then with all of that information, now you can target the algorithm, the AI algorithm, to identify or to create an inference model that will look specifically for what it was that you identified in that data as ground truth. Data science is a broad term that includes a number of things, one of which is deep learning and machine learning. Machine learning is the ability of a machine to provide intelligent solutions, essentially make predictions based on large amounts of data that it's been trained with. In deep learning, that's typically used to describe the layers inside of that machine learning solution. And when there's many, many layers of abstraction, that's called deep learning. So there are various solutions for deep learning. There are various solutions for machine learning. And when at the end of that machine learning process, you have what's called an inference model that's been created from the data and the algorithm combined, that is now, the colloquial term for that is artificial intelligence. So when you apply machine learning in an environment, and it actually works and it's demonstrating that it's affecting the capability of making an inference, that's often called artificial intelligence.
Did you want to speak about when you're talking about
Because supervised learning is used heavily in AI today, we need to be able to create those annotated data sets. To create annotated data sets, we have to define the use case so that we know what to annotate the data with. The Data Science Institute, therefore, is focusing a lot of its initial efforts on defining what those use cases are. When we do have use cases defined by experts that have defined a particular subspecialty and a particular examination and a particular finding within that as a use case, then we can make that available for those that have large amounts of data to structure those with annotation tools. They can structure that data so that then algorithms can be performed, and at the end of that process where the inference engine gets created, the inference is capable of supplying the information for that use case that we initially defined. So when the Data Science Institute identifies use cases, it will have the ability to work with industry, to work with hospitals, to generate the solutions that then can be put into clinical practice, providing that use case to radiologists and to our patients. Does that make sense?
Yeah.
And good.
There are various ways that radiologists can get involved in this field. For example, oftentimes radiologists are in the regions or locations where there are vast amounts of data, either in your private practices, your affiliation with hospitals. It's this data that actually creates the algorithms, it creates the models. So the notion of having that data in a secure place, being able to organize it in large concentrations and be able to annotate that is exactly what the vendors are looking for. It's exactly what is necessary. It's essentially the fuel that fires the rocket of artificial intelligence. So the notion of creating that data into a structured solution is essential. Other ways that radiologists can be involved is as a recipient of artificial intelligence. What is it that you want the AI to do for you? How would you include that and incorporate that into your practice? How do you make sure that it's delivered in the most efficient way for you and optimally for your patients? So there are ways to become engaged with the Data Science Institute where those are some of the things that we're looking at. How to educate various personas, radiologists, other physician groups, and patients, as well as the ability to understand how it needs to be incorporated into the clinical setting. The intent of the Data Science Institute is to work with our members to educate, but also to capture information and to make it so that the process of integration of AI into our practices is more streamlined than it would be otherwise.
Rolling. Make sure my settings are the same. I just switched batteries.
Because of the fact that artificial intelligence will be created through the use of data, and data resides typically at hospital locations or inside of practices, it is the intent of the Data Science Institute to work with those organizations that have the data to help them to be able to understand how to make that data valuable, how to create annotations around the data so it can provide solutions when combined with AI algorithms, create the inference models that can be used inside of our practices. We don't see a situation where the ACR will bring large amounts of that patient data into our walls because of all the issues around protection, confidentiality, security, ownership, rights, all of the things that each institution needs to consider. So instead, what we hope to do is to create tools that will enable those data-rich institutions to actually create that data in a structured sense to be able to work with industry or take algorithms themselves and create AI inference models directly.
All right, and we are rolling. Might want to focus on that camera. It's bigger, a little sexier.
We're not talking about cameras.
Are we ready?
Let's see here. Close that up. Thank you.
All right, we're ready when you are.
Okay. There are different types of data sets that are necessary for artificial intelligence. I think of them as three. There's training data that's necessary to create the inference engine, which has to be annotated, including ground truth, because this is all structured, supervised learning with narrow AI. The second is a validation set. So once you have the algorithm trained with the training data, you have to validate that the inference engine actually works at a certain percentage of accuracy. That also has to be annotated in the same way. And then finally, we see with the Data Science Institute a more comprehensive solution across the nation of a validation set. So when data is used to train an algorithm and then there's testing with another data set, that's typically a regional solution. But the question comes, does that work in all populations? Does that work on all scanners? Does that work in various settings, different pulse sequences, protocols? And so a broader solution we feel is necessary for patient safety to make sure that there is a verification set available. And this is essentially post-market surveillance of the product. And we find that vendors that are beginning to expand solutions in this space appreciate this type of solution that the ACR and Data Science Institute can provide. That's a good point.
Good to go.
Artificial intelligence is already available in many fields. In fact, we use them in many different ways today. When you use your iPhone, when you look at images on Facebook, or when you go into search algorithms, AI is inherent inside of many of those solutions today. Oftentimes when AI works, people say that it's not called AI anymore. It's just called a feature or a function of that device. I think the closest correlation I see to medical imaging and the use of AI is probably in automotive. So when you think about the notion of what's going to come next in automotive automation, autonomous vehicles, we probably won't have a vehicle driving itself 100%, but before that we will have solutions where there's, say, collision avoidance or pedestrian detection or lane monitoring. So those are solutions that I would call narrow AI, and those assist the driver. I think we're going to see something similar inside of radiology, medical imaging, and healthcare in general, where it's the combination of narrow AI solutions and the human that will be providing better care. So what are the narrow solutions? What are the lane assist analogies inside of healthcare or inside of medical imaging? That's what the Data Science Institute will focus on, is defining those use cases in what it is that we do. And we'll use membership and we'll use volunteers to create panels that will define those in a very practical way so that the solutions that vendors will provide will be the things that we need. At the Data Science Institute, we feel strongly that radiologists need to be the drivers of this technology. Imagine a situation where radiologists weren't engaged in the process of creation or management of the concepts around this. Vendors would do the best that they could. They would create solutions that sometimes might help, sometimes might hurt. what it is that we would want to have as solutions. So we picture radiologists being able to drive this technology to create standards, definitions, implementation frameworks, so that radiologists can work with industry and have industry provide solutions that we need. Again, it's similar to DICOM and what it did for digital display, for PACS systems, for storage systems. If we, the ACR and radiologists, didn't create those standards, there would have been a wide variety of solutions that might not have been compatible with each other. Instead, with data science, we have the opportunity to create use cases that will help to build narrow AI, that will integrate into our solutions that are optimized for exactly what it is that we feel that we need. This helps radiologists, it helps the industry, and it helps our patients.
Great. Whenever you're ready.
Okay. If you think about the technology that we've had the fortune of having deployed through our institutions over the last 20, 30, 40 years, image data has become much more dense. There's a higher volume of pixel data, and yet we're doing the same interpretation, rendering similar outputs as a radiology report. Yet we have the opportunity to create quantified data out of this massive amount of data that's coming to us at the point of interpretation. At the same time, efforts around precision medicine are taking place, where I think radiology can play a large part in that, in the diagnostic process and the diagnostic data that can help that precision medicine need. So as we deploy artificial intelligence into this space, we have the ability to take that vast amount of data that's being created at the scanners, do analysis on it, and create quantified output. Being able to do quantification, radiomics, and enter that data into the EHR along with our interpretation that we see as it goes through the process. Now we have vast amounts of structured data that can be entered into the EHR, putting us, radiology, deeply involved into the precision medicine field. The ability for artificial intelligence to quantify output from scanners allows us to take that data, include it with our interpretation, push that data into the EHR, and use that as a basis for precision medicine.
Great.
Yeah,
Excellent.
I like that better.
Yeah,
Sure,
thanks for
good point.
Yep.
Um,
Okay. All right, we are rolling, and whenever you're ready.
As we use artificial intelligence to identify findings and quantify those findings inside of medical imaging, and the ability to move that over to the electronic health record, we now enter a state of precision medicine, which lets us look at large populations of patients. So now we can look at risk pools of patients, which helps our colleagues in population health management. Diagnostics really drives a lot of population health and decides which patients are at risk. Oftentimes when we move the data into analytical systems today, it's our results, it's our interpretations. You can imagine the value that would be added if we were able to add structured data into that analytic process. So as risk pools are determined, as optimized care is defined for patients in and at risk, we have the concept of creating radiology tools, artificial intelligence tools to augment that data that our colleagues in pop health management are able to use to identify those patient groups.
All right, and whenever you're ready.
If you think of AI like other technology that we've seen, for example, a new modality, oftentimes they come in a kind of a crude or raw form, and then over the years and decades they become much more fine-tuned, much more optimized. In our experience in radiology with these new technologies, we've oftentimes been at the forefront of optimizing or sharpening that tool. I think the same thing will be true for artificial intelligence. It's hard to predict what will happen in 10, 20, 30, 40 years in this domain, in this technology, or in other technologies. But I can say that if we stay at the front of this, if we stay involved with the sharpening of that tool, it'll be optimized for our patients, optimized for our use. The technology will probably advance such that it will do things that we couldn't conceive of today. If you look back 10 years ago, The technology wasn't there to do the things it can do today. So in 10 years from now, it will probably have the ability to do things that we wouldn't conceive of today. Regardless of that, though, we need to position ourselves in front of this technology so we can guide that which we know and that which we don't know, which is to come, with the focus on making this optimized for patient care and improving quality.
And whenever you're ready.
While radiologists have the opportunity to create much of this technology or be engaged in the process with industry to create the technology, most of us are going to be consumers of the technology. So what is,
Sorry.
ready?
Hmm?
While radiologists have the opportunity to create much of this technology or to work with industry to create the technology, most of us are going to be recipients of this. Similar to the autonomous vehicle, where we're going to buy the car that's going to use artificial intelligence to optimize our experience in the car. We are going to be the recipients of this technology in what we do every day. How do we prepare for that? Well, one of the things that the Data Science Institute plans to do, how do we prepare for that? One of the things the Data Science Institute will be doing is educating radiologists on what's to come. Education is critical for you to be able to see how to include this into your practice. And focusing on how to improve your practice and how to incorporate artificial intelligence into your practice is going to be an ongoing opportunity that you have to improve patient care.
And ready when you are.
Okay. Well, it's an exciting time in healthcare. We're awash in data, and we're beginning to leverage compute power to really process this. So at the Data Science Institute, one of the key things we're trying to do is to help radiologists leverage evolution of technology, the availability of large amounts of data to begin to automate tasks and help them improve a lot of the activities that they do on a day-to-day basis. Okay. Well, it's an exciting time in healthcare. We're awash in data and beginning to leverage compute power to automate tasks that let us help leverage that data. So at the Data Science Institute, we're looking at this evolution in AI and the availability of tools to help radiologists improve what they do. All right. So it's an exciting time in healthcare. We're awash in data and beginning to use compute power to help process that data. So at the Data Science Institute, we're looking at artificial intelligence and the evolution of techniques in data science to help radiologists leverage data to improve patient care. The process, so we're involved in a number of tasks related to, okay. So some of the activities at the Data Science Institute really follow the life cycle of the development of an AI algorithm. So it really starts with defining the use cases. And here we're looking to identify the areas in clinical care that are going to be most useful to the radiologist and to patient care. Once we have the use cases defined, then we can work on the process to verify algorithms. So as algorithm vendors begin to address the problem areas we've defined, we then work to make sure they're ready for clinical use. And then finally, the last piece is to move these algorithms into the clinical workflow. So here we're working with radiology workflow vendors and algorithm vendors to define standards and ensure we can actually get these into the radiology workflow and get them in service of patient care. I lost track of what else we were.
All right, this is our take two, and whenever you're ready.
So one of the things that differentiates some of the current AI techniques from past techniques is the current techniques are focused on using data to help algorithms continue to learn. So to make that happen, that means data is king. So at the ACR, we're helping match algorithm vendors with facilities so that we can provide data to help them develop algorithms, verify algorithms, and continue to evolve that process. Yeah.
Yep.
So one of the things that differentiates the current types of algorithms that we're seeing in AI versus some of the past is that the current algorithms are really learning machines. And to really make those machines work, data is critical. So this means training the algorithms on large data sets, and then also allowing the algorithms to continue to learn as more data is processed.
All right, and whenever you're ready.
So some of the buzzwords that are currently used can be a bit confusing. So let me talk a little bit through some of the buzzwords that are being used can be a little confusing. AI has been around for a while, artificial intelligence. And there are techniques dating back decades that where programmers provide rule sets so that algorithms can behave intelligently like a person will. Machine learning is a subset of AI where machines actually learn. So they take in data, they process data, and continue to evolve. And so it's no longer based simply on static algorithms that programmers come up with, but actually evolving learning machines. Deep learning is a subset of machine learning. So with deep learning, this is now applying a technique called neural networks, which is modeled after the way human brains work. And this particular technique is very compute intensive. And one of the reasons why that's become really popular as of late is because it's been able to leverage graphical processing units, GPUs, which are really developed for graphics processing, but they happen to work quite well on heavy compute and parallel processing. And so suddenly algorithms that were very difficult practically to do in the past, we're able now to do on fairly inexpensive hardware. Okay.
All right, whenever you're ready.
So some of the limits of the past techniques is they required computer programmers to provide many lines of code to accomplish a particular task, and then improving the algorithm required more programming. In the current landscape, when you've got a machine learning program, the machines actually themselves learn based on data. So more and more data feed these algorithms. The algorithms get better and continue to evolve. And so this becomes a very data-centric activity and an ongoing learning process. I can rewind that if you want to do that again.
And whenever you're ready.
So our goal isn't to develop algorithms. There's a lot of exciting work being done creating new and better algorithms to interpret images. And our goal is to facilitate that process by focusing on clinical problems that are most relevant and provide the biggest opportunities to improve patient care, improve the workflow, and generally make the process a better one. I'll go back. So our goal isn't to develop algorithms. We see a broad vendor landscape with a lot of excitement around creating new and better algorithms to improve the radiology workflow and impact patient care. Our goal is to help focus the algorithm development in areas we feel are most productive, to provide the means to help algorithm developers continue to evolve their algorithms. That means collecting data. That means identifying ground truth. And then ultimately help pave the way so these algorithms can make its way into the radiology workflow.
That's great.
Yeah.
Sorry, Dr. Dryers.
Oh, is he?
What are you doing?
causing trouble.
Rolling. All right, whenever you're ready.
So we're at a very early stage in the process. We're just beginning the process of developing use cases, and there's opportunities for our members to be heavily engaged in that process. We think it's critical that radiology take a real ownership role in defining the areas that are most important for clinical care. We see opportunities to help algorithm vendors in verifying algorithms, in training algorithms. That means matching members who have data with the vendors that need data.
And whenever you're ready.
Okay. So the first part of the process will be training these algorithms. Once they've been trained and validated, then they'll be deployed in clinical care. And at that point, you really have a model that's going to be continually used to provide assistance in the clinical process. I'm going to wind back on that one. So the first step in the process is actually going to be to develop the algorithm. And this is going to be a process of training the algorithm with large amounts of data, validating that the algorithm actually addresses the clinical target, and then deploying it to a clinical environment. Once that algorithm is done, we now have a, all right, I'm going to go back. So the first part of the process is developing the algorithm, and that really involves a training process, and that training process requires large amounts of data. And once that model's been trained, we'll then verify the model or verify the algorithm against the first part of the process is to develop the algorithm, and this involves a training process, and this training process involves lots of data. Once the model's been trained, we then go through a verification process, and then we can deploy that into the clinical environment. And at that point, it's going to function in a way that's going to continue to ingest data, provide results until that model's then updated. Now, continuous learning models will continue to evolve. In the short run, we see more likely static updates to models, so that over the course of time, as the models become smarter, we'll keep deploying versions into production. All right, let me. Okay, I'll do it one more time. So the first step of the process is to develop the algorithm, and that development task involves the ingestion of lots of data. And once that algorithm's been trained, then it goes through a verification process. So the verification process takes established ground truth data and verifies the algorithm meets the clinical targets. And once that's done, the algorithm is now ready to be deployed as an AI model. Now, once that AI model is in production, it's going to continually ingest data and provide the clinical answers that it was created to deliver. Over the course of time, that algorithm will be updated as we go. Okay, go back. Over the course of time, we'll continue to repeat that process. So the algorithms will be updated, again verified, and again deployed into a clinical environment. Ultimately, some of these may be continuously learning models so that they continue to get smarter as more data gets ingested. So the process starts with an algorithm being trained, and that requires large amounts of data. And once that algorithm is trained, then we go through a verification process. So the verification process requires we have ground truth data, and we can test that algorithm against the expected results. When that process is finished, then it's ready for clinical care. At that point, the algorithm is deployed as a static model, and it can be used in a clinical workflow environment, in this case, a radiology workflow system, to provide answers to radiologists that target the clinical concerns that the algorithm is developed to address. Over the course of time, these algorithms will be updated, and that will entail repeating the process that I just described, so that we ingest data, retrain the algorithm, verify, ensure that it meets the clinical targets, and then gets deployed again into clinical care. Some of these models are continuous learning models, so that the algorithm actually updates as it ingests data. This process will require particular vigilance on the verification scheme to ensure that as the algorithm learns, it continues to remain accurate per the target that the clinical designers intended.
Spades, and whenever you're ready.
Okay. There's so much excitement in this space right now, and so many vendors that are providing really exciting technology that it's critical we find ways to focus everybody on areas that have the greatest potential to improve clinical care. So one of the things that we've been particularly working hard on is the creation of use cases so that we can help focus our attention on areas of greatest clinical impact and help focus the vendors on those areas as well. And we've gotten overwhelming excitement from the vendor community who are looking to solve the most important challenges. So we're working with both the algorithm vendors to help understand the targets that are critical, but then also helping the next phase, which is actually getting these algorithms into clinical practice. So for that to happen, working with the clinical workflow vendors as well as the algorithm vendors to ensure we have standards and a clear pathway to move this technology into radiology care. I can do that one more time. This is clearly an exciting time in AI and the use of data to help improve clinical care. And that's not just true in radiology, that's across all of medicine. So in the short term, we see some rapid advances in areas that AI is best suited for. So we call, this is an exciting time in AI and the use of data and technology to improve patient care. In the short term, we see the need to work on a whole host of clinical problems, workflow problems, in order to improve the day-to-day lives of radiologists and the care of their patients. Over the course of time, we'll expect this technology to continue to evolve, but that just creates more and more opportunities. So like most technology revolutions, the tasks that technology can handle evolve, but in the end, they tend to focus on those things that are most routine, most repeatable, and allow individuals to continue to move into areas of greater and greater value that are less routine. And just like we see that in other industries, we expect the same thing in healthcare and the same thing in radiology. There's no question that people's roles will evolve over time, but our expectations are that we're going to find new ways to leverage the technology. We're going to help focus the technology on improving the radiology workflow, improving patient care, and continue to improve overall the experience for radiologists and patients. That was a fairly... So there's so much potential for this technology that the first key question is what clinical problem to solve. So we characterize this as a use case. This is what's the clinical problem, what's the intended result of the algorithm, what kind of data inputs does the algorithm need to do its job. And so once you have that use case defined, then you give the algorithm vendors a very clear target to hit. And that allows us then to measure the results of their labor. So our verification process is to then look at the created and trained algorithms and ensure that they in fact map back to that use case, that they achieve the desired goal. And this is all critical for us to be able to provide algorithms that achieve particular clinical purposes and have a place in the clinical workflow. So the next step after we've got these algorithms created, validated, addressing particular use cases, is then to embed them in the radiology workflow. And for this, we've been working with both the radiology workflow vendors as well as the algorithm vendors to ensure we have a smooth pathway, so that as these use cases get developed, as algorithms get developed to address these use cases, we can rapidly get them into clinical practice.
Great. Good. And we are rolling. So whenever you're ready, into that camera.
We know we're in the era of patient-centered care, and it's going to be critical with the college's emphasis on the Imaging 3.0 strategy that we look at all three components of Imaging 3.0. That is aligning incentives, a culture change, and developing tools to assist the radiologist to be more than simply a study interpreter. I think that's where artificial intelligence has the most potential to allow radiologists to become more patient-centric, allow them to have time as opposed to the total productivity-driven era that we've gone through in Imaging 2.0, to consult with referring physicians, guide referrers to the best tests, be able to discuss with patients their results, and as a result be part of the team-based healthcare that we know is going to be the paradigm of the future. So again, artificial intelligence assists the radiologist. When I was beginning practice, a CT of the abdomen pelvis might have 60 images, where now there's probably 2,000 images. Well, to have that assistance in analyzing that high volume of images, to be able to concentrate the radiologist's time on those images that are of critical importance, and then have the time to, having guided the referring physician to the right test, be able to discuss those results with that referrer as well as the patients.
Are you ready?
So there's great concern out there in the radiology community of, is artificial intelligence or deep learning going to take radiologists' jobs? And I think actually the exact opposite is true. It's going to empower radiologists and enable us to, again, be a major team-based healthcare provider. and work with the other physicians, be able to mine through artificial intelligence, the content of electronic health records, to be able to be more specific in our interpretation of various findings, and also to make sure that we've used all the data that's available. It should not be seen as a threat to radiologists. Rather, it should be, again, an enabler. I think that there's a lot of information out there across medicine and, in fact, across all professions of things that can very capably be done by computerized processes. But without the human touch that comes with the radiologist being actively engaged and partnering with those tools, you really lose an awful lot of what's going to be, I think, the positive healthcare experience for patients in the future. After all, patients are really the center of our focus.
Whenever you're ready.
In a very proactive fashion, the college's Board of Chancellors identified the rapid changes in the environment and relative to deep learning and artificial intelligence. And as a result, formed the Data Science Institute under our Commission on Informatics. We want to be proactive, just as we were back in the beginning of the DICOM era when there needed to be interoperability of images from multiple different vendor scanners. We want to be similarly guiding the process of the development of the artificial intelligence world so that in fact it does exactly what it's intended to do and going to be most capable of, and that is making sure that the radiologist is fully equipped with all the information, assistance when necessary as far as evaluating large volumes of images, but most importantly, I think that the Data Science Institute has to make sure that any algorithms that are developed by engineers or others who are in the process of computer experts doing that they're doing it for use cases that really make a difference in patient care. To do an algorithm that has no quality or improvement or no value to that patient care episode is really not going to do anyone any good. Secondly, there are going to be developers that come forward with programs that, quite frankly, may not be accurate. And so the validation process of making sure that if a scanner of a given manufacturer produces such and such an output, that those measurements can be extrapolated to other scanners or other acquisition protocols. So it's going to be really key for us to guide this process. It's here to stay, and as I say, here to stay not just in our industry but all others. But the college's effort through the Data Science Institute is to in fact guide that to optimize radiologist performance and patient care. It's important to recognize that even with all of its capability, artificial intelligence and deep learning requires the guidance and oversight by humans. I think it's just like the analogy of flying in an airplane. I think though most of the airplane guiding systems are computer driven, the fact is that none of us are going to get on an airplane without a pilot in the seat. And that radiologist who's going to be the pilot of that imaging or minimally invasive treatment care is going to be aided by and enabled by the artificial intelligence, just as a pilot is enabled and assisted by those instruments and computers within that airplane. The fact of the matter is that the combination of the intelligence, humans are growing in intelligence all the time. The combination of that with the assistance of the computerized processes will far exceed the capability of either. And that's why we really need to embrace this technology and, in fact, use it to the betterment of the care that we can deliver.
And whenever you're ready.
Though there are incredibly talented computer engineers that are going to be working on and developing these algorithms, they have no concept of the clinical context into which it needs to be placed. And I think radiologists will be able to help involve those people from their computer expertise, but guide them through our clinical expertise and background, education, and experience to make sure that those algorithms are in fact something that's going to aid that patient. It doesn't make any sense for us to, I'm sorry, I sort of lost my thought there.
Yeah, you don't have to go all the way back, just kind of, if you can pick up just.
The concept of several young engineers getting together in a garage in Palo Alto and coming up with an algorithm that may, in fact, they think is going to add some value. It's foolish of them to think that they don't have to fit this into the clinical care episodes. And just as all of us, as a radiologist, when we had an upgrade in our PAC system and we cringed at the thought of coming in the next day finding a lot of its capabilities gone because an engineer might have thought a new bell or whistle was a good idea, we don't want these algorithms to go forward and in fact potentially confuse as opposed to contribute to that healthcare. There's a long history of radiology and industry being partners in the development of our incredibly advanced technological imaging chain and treatment procedures to date. And there's no reason that this can't be exactly the same in this new development of deep learning and artificial intelligence. We each have our own perspectives, talents, and qualities to bring to this development, and I think it's going to be incredibly important that the college, as well as other radiology organizations, works with industry, hand in hand. One of the major challenges is going to be interoperability. How can algorithms built on one system talk to and inform those on another? Patients commonly move between healthcare systems, and if in fact there are different algorithms being used by them, they've got to be able to communicate and make sure that that care is properly done with consistency across the different healthcare systems and environments. So again, I think it's really critical that the college, and we fully intend to through the Data Science Institute, work with and enable industry just as they enable us with many of the technological developments, and in this case algorithm developments that we'll see as this advances. Reasonable?
That's great. And Roland?
Like all of us, I'd love to have a crystal ball and know where we're going to be 25 years from now and what the impact of these developments will be. It's changing rapidly. There's a great quote by Jim Collins, who in his book Great by Choice said something along the lines of, there is no new normal because we're in a state of constant change and we have to be ready to adapt. But I do say that if I were a young person coming out of medical school, as I was 30 some years ago, and had the opportunity to choose a specialty, I would be drawn to radiology because of the excitement that this is bringing to the specialty and to the profession and to our capabilities to become major contributors to the healthcare of our population. The ability to participate in population health as well as the individual patient care, I think is going to be driven by these artificial intelligence and deep learning processes. So yeah, if I look down to the road 25 years, I would be happy to be involved in this specialty, and I hope I'm still around and I have the opportunity to see all the unbelievable developments that we anticipate.
And whenever you're ready.
It's really important to understand that artificial intelligence and deep learning is not simply about image evaluation by computers. There are huge streams of data that are being collected now like never before. And using these computer processes, we'll be able to look at population bases to see who's at risk for given diseases. How do we best customize their care? How do we best customize surveillance in order to make sure that we detect disease early rather than later? There are many projects going on now that are developing incredibly large databases that evaluate, let me go back. That are collecting incredibly large databases that will allow us to evaluate propensities of population segments for different diseases. And we'll be able to customize care as opposed to some of the broad stroke treatments that are done now. I think that'll be both economically advantageous in order to be able to use our limited resources in healthcare and make sure we get the best bang for the buck as far as taking care of those populations.
Whenever you're ready.
I'm proud to say that radiology, and in fact the American College of Radiology, is on the forefront of this. This is going to impact, as I mentioned, all specialties in medicine, not just image interpretation or visual recognition specialties. And I think it's critically important to know that radiology has stepped up. In the recent book, The Digital Doctor, radiology is described as on the forefront, or the canary in the coal mine of these information technology developments. I think we're very fortunate, and I think, again, that makes it a very attractive field for medical students to look at as one that's going to guide us into the future, rather than one that's going to have their positions taken over by computers.